Okay, so in this lecture, we are going to cover one of the most important principles in calculus. Okay, not only in this course, but if you go on to do this later, general calculus, okay, this is one of the most fundamental and important principles. Why is it so important? It's important because whenever you have to derive something that's even reasonably complex, you will be losing this, okay? This is called the chain rule. Okay? To me, like personally, that's a very good name because it's so common in differential calculus. It kind of like holds everything together. It's like the basis of everything, you know. So it's an appropriate name. It's like a chain holding everything together. Okay. Now, regardless of its importance, it's not something to be scared of. It's a pretty simple concept, and hopefully, after we explain it and you do some practice, it starts to feel intuitive and easy. Okay. And we're going to do this by using an acronym. Okay. Now, let's explain this with an example. Say we have this function here. Okay. We have the function y is equal to x cubed plus x plus 5 to the power of 10. Okay. And we are asked to derive the function. Okay. Now, we could just try and expand it all the way and then derive one by one, do the whole process. But as this power here, as this starts to get bigger and bigger, this method becomes very impractical. You can't just sit here and do it one by one all the time. Okay? So instead, we're going to use the chain rule and we're going to use it with this acronym. Okay? RIET or RIET. Not sure how it's pronounced, but that's the acronym. Okay? So how are we doing this? What's the first step? The first step is R, okay, which stands for replace, which means we're going to introduce a substitution, okay, or a substitution, okay. Let's see. So we're going to say let u equals whatever is inside this bracket. Okay, in this case, it is x cubed plus x plus 5. Okay, so we're saying let u equals this, therefore y is equal to u to the power of 10. Right? So that's it. That is our R done. Okay, now what we do is we have two functions, okay, u in terms of x, and we got y in terms of u. Okay, what we're going to do is we're going to differentiate both of them. Okay, so we're going to do this one first, du on dx. Okay, so the derivative of u with respect to x is 3x squared plus 1. Okay, so that is our inner function because it's on the inside. Okay, so that is our inner function derived, hence the I. Okay, now we're going to do the second function, which is our outer function. Hence, this will be our O. Okay, so this is dy on du is equal to 10u to the 9. Okay, this is our O done. Okay, it kind of looks like a donut, but that's your O. Okay, so now we do the most important part of this whole process, the t. Okay, what we do is we've derived two things. We're now going to put them together. Okay, that is why the t. All right, and how are we going to put them together? We're going to do this. Okay, well, we get your thing that you're looking for. So we're trying to find dy on dx, right? And then you get your derivatives that you found and you multiply them with each other. You go dy on du times du on dx. It's important to multiply, okay? And then, well, then you, let's substitute in what we have, okay? Dy on du we found was this. Du on dx we found was this. Because of the x's, I'm going to get rid of this multiplication sign here, and we're just going to work with brackets. Okay? So that is what we have. We're going to, obviously, we introduced the u, so we can't leave that in the answer. So we're going to substitute back what we had for u, which was x cubed plus x plus 5, all of that to the power of 9, and then 3x squared plus 1. Okay, and there it is. Voila. You have the derivative that you were looking for without doing millions of expansions. Okay, very, very good. Now this is a very simple process, right? It's quite straightforward, but if we zoom in here, right, if this is the whole essence of the chain rule. This is the chain rule itself. All of that is just a process using the chain rule. This is the chain rule itself. If somebody asks you for the definition, this is what you tell them. dy on dx is equal to dy on du times du on dx. Okay? And it works kind of because the du's cancel out. Okay? That's sort of what is happening. But this is a fundamental law in calculus, and this is why the whole process works. Now, I said this is a very important thing in calculus, but from this example, it may seem like it's just a shortcut. All right? But actually, whenever you have any sort of complex function like this, okay, like you have sine of x squared plus 3, you're asked to derive that. Or if you have, like log of cos x, okay, you're asked to derive that. Or if you have e to the sine x, okay, you're asked to derive that. Wherever you can see that you can replace, substitute something, wherever you can see that you can use your r, here this becomes a u, this becomes a u, this becomes a u. Wherever you see that you can put your substitution in, wherever there's a function within a function, okay, that is where you can use the chain rule. And you will be surprised how often that appears in calculus. When it may seem like an odd chance, but it happens a lot where you have a function within a function, and that's why the chain rule becomes very, very important. And that is exactly why you should pay a lot of attention to the worked example section for this lecture. Okay? There are going to be a lot of practice questions that you should be doing. And obviously, the more you do, the more familiar you get with this. And the more familiar you are, the rest of the course gets a lot easier. Because like I said again, these pop up a lot. So you need to have a strong skill set over here.